question then arises, how do we use duration? And the duration measure, in effect, is intended to estimate the impact of a change of interest rates on the value of a bond. So if we know what the bond price currently is, and we know the change in the interest rate, and we know the original interest rate, if we take the product of these two by negative times the duration, we can estimate the effect of a change of that interest rate on the bond price. So we can estimate the change in the bond price. Now this is just an estimation, and so if you like, the duration formula doesn't give us a complete picture, but nonetheless it's widely used. So let's just paste and try to understand how duration might be used. So essentially, let's say we have a bond, and let's make a little bit of space here. So just insert columns and pull this back over, and we have the duration of the bond. So this is D, if you like. So duration of the same bond. And let's say we increase, so this function here is the present value of the bond, and because it's a par bond, because the coupon rate and the discount rate are the same, the value of the bond is equal to its face. So we could say this is the bond price. We could take this as being P. Right? And if you like, if we took the same set of values again, and let's just change a little bit currency and currency. Okay, and let's say we increase very slightly the interest rate in the bond. If we increase the interest rate in the bond price should fall. So the bond price falls, and it falls by how much? So minus 1,000, the bond fell by 768. Okay, now using this formula here, we could have anticipated, so that's the actual DP, and from duration DP would be equal to negative times, let's just make this a little bit bigger. Okay, so, and I'm going to try to replicate this result here. So equal to, we're going to say negative D, is this value here, because that's what we worked out the duration to be for this bond using our function, times the change in, now the change in the interest rate here, we could say is equal to this value minus this value. Okay, and we divide that by 1 plus the original interest rate, so 1 plus R, and then we multiply that by the original face value, and the change in the bond price should be in this region, but not exactly. Okay, so from duration we would anticipate for this level of change in the bond price, for this change in the level of the interest rate of 2 basis points, the value, using the duration model, we would have anticipated the bond price would have fallen by 737, but the true fall we know to be 768. If we made this actually smaller, it tends to become somewhat more accurate. Okay, so 74, if we make it smaller again, there is a, let's increase the So let's take this up. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so for an even smaller change in the interest rate again, so 0, 2 again, okay, it becomes somewhat more accurate. Okay, so for large changes in interest rates, duration tends to be less accurate, right? So if we increase by 2%, or if we increase by 0.2, right, 30 cents, if we increase the interest rate by 1 basis point, right, the difference between the true fall in the interest rate and that predicted by duration tends to diminish somewhat. Okay, if the interest rate actually change this to 0.998, right, similar results. Okay, so in effect what we can do here is estimate the effect of a change in interest rates in the bond price. If the original bond price was 10%, sorry, the discount rate or yield to maturity was 10%, and we increased that by 2 basis points, the value of the bond would drop by 768, whereas from duration we would predict using this model the value of the bond would have fallen by 737, and this drop tends to be less dramatic compared to this, and that's because duration is linear, whereas the true bond price is convex. So duration is a linear relationship, whereas the true bond price, as we would have seen before here, the true relationship for different interest rates. So if we start with a bond of interest rate of 10% and interest rate of also 10%, we get our par bond. If it was for 5 years, okay, we get a par bond 10% 5.2. If we change this to 20 years, 30 years, we can see that the relationships become even more convex, right? So if we re-estimate the bond for different interest rates, the bond price we can see is not a straightforward linear relationship, it's actually convex. The true relationship between interest rates or yield to maturity and the bond price is non-linear, is convex, whereas the duration model assumes that the bond's relationship with interest rates is linear. Okay, and that's why we're getting a breakdown between the actual change and the change forecasted by duration.